Assalamu alaikum, dear students. You are welcome over here in lecture 21 of fermentation and its industrial applications, where we were studying downstream processing chapter. And in downstream processing chapter, how we can obtain our desired product from fermenter. We have studied various techniques. So here we are talking about the crystallization. If I will show you here, you will be with me on the slide. Here we have to see this thing, crystallization. It is also a technique by which we are purifying our desired product from mixture. This is most specific, unique, and efficient technique which makes sure 100% pure separation or purification of that product. So some limitations of this technique are also there because for every substance, for every type of product, we cannot use the crystallization. So first we will see what is the crystallization. So crystallization is a process of formation of solid crystals, solid crystal, precipitating from a solution, melt or more rarely deposited directly from a gas. So conversion of any liquid or gas into solid form is called crystallization. Chemical solid-solid separation technique in which mass transfer of a solute from the liquid solution to a pure solid crystallization phase occurs. So this is very specific technique. Actually, what we are doing in this technique just we are applying any condition or any chemical which converts our desired product into crystal form, which becomes solid in solution, and other contaminants and other molecules are living in liquid form. So we have to discard the liquid portion and we have to isolate and obtain the crystal, which is our desired product. So for every type of fermentation product, it cannot be used, but special products which have ability to be converted into crystal form by any mechanism, by any chemical, or by any process, or by any condition, that desired product converts into solid form and other remains in liquid form. So this is also a good technique. At last stage, when we obtained first, we obtained our we did fermentation, we separated all waste material, different materials from that product, and we isolated our product. At lastly, we purified our product. Now it is our responsibility that we have to polish our product. So here arises a question why we are polishing our product, because in market there is a competition of the product and people have to attract the customer. If product is not aesthetically acceptable for the public, for the consumer, so in market the competition we will lose. We cannot win the competition. So therefore we have to polish our product and with packaging of the product in a form that is stable. We are going to polish and we are packing it. For what purpose? It must be stable in market. It must be easily transportable due to that coating, due to that packaging, and convenient. So for this product polishing, we have crystallization, desiccation, lypholyzation, spray drying, may include sterilization of the product, remove or deactivate trace contaminants which might compromise product safety, virus or dehydrogenation or dehydrogenase enzyme activities. So we are doing such techniques in crystallization. In crystallization, we are converting it into crystal form, and we are packing these crystals in a mm, stable and good and attractive covering that people will accept it easily. Sometimes we are desiccating it, sometimes we are converting into powder form, uh, that is called lypholyzation, in which we are using low temperature and converting product from solid to powder form without, from ice to powder form without converting into liquid phase. So spray drying, we are including this technique. Localization, freezing the material, reducing the surrounding pressure, and adding enough heat to allow the frozen water in material to sublime directly from the solid phase to gas. So localization is also a technique in which we are freezing the material. We are using localization for freezed material, reducing the surrounding pressure. We are reducing the pressure. We are reducing. So what happens? Due to this, we are applying some amount of heat, which converts solid into dry form, solid into powder form, removes water uh, in crystal form, not allows it to be converted into a liquid form. So reducing the surrounding pressure and adding enough heat to allow the frozen water in the material to sublimate directly from the solid phase to gas. It will convert from solid to gas, and your product will live in dry form. Specific and advanced devices and instruments are available in market and in organization, which can be used for this purpose, especially for those samples which are sensitive to temperature and you want to keep it for longer time. So what we are doing, we are localizing it, we are converting it into powder form in freezed condition. We are reducing pressure, we are giving some temperature in which uh, ice converts into gaseous form without converting into liquid form, and your product remains in powder form. So localization technique. So current research in this regard, uh, what takes the direction? A study on the downstream processing for the product of uh, pollen. But for this is this one is the topic. Eurobacterium pollen SP1 from the fermentation process. How we can isolate this thing? So we have to study this case over here. Pollens made up of linear alpha D glucan maltose and maltotetrose nitroconnectase by alpha 1 6 alpha 1 4 linkage is a water soluble hemopolysaccharide produced extracellularly by Aerobacterium pullulans. So first point we have to see this thing. Pullulan made up of linear alpha D glucan, maltotriose, maltotetriose are connected by the alpha 1 6 and alpha 1 4 linkage in water soluble homopolysaccharide produced extracellular by Aerobacterium pollen. This is produced by Orobacelia pollen. Okay, this microfungus which is producing this substance. It is necessary to harvest the cell. So we will ferment this thing and they will produce this material. Orobacterium pollen will produce this material. So it is water soluble substance. So it is necessary to harvest this cell remove the melanin pigment co-produced during its fermentation, followed by its precipitation, concentration, and drying. So for this product, we have to apply this type of technique. It is necessary to harvest cell, remove the pigment as a co-product produced by microorganism during fermentation, followed by we have to precipitate it and concentration and drying. So centrifugation of fermentation broth at 8,000 rpm for 20 minutes gives cell pellets that were discarded and greenish black supernatant containing melanin pigment. Centrifuge. So for this, what we will do? We will take broth, we will centrifuge it at this speed for 20 minutes. Cells that have discarded and will discard and a greenish black supernatant containing melanin pigment. It was then subjected to the heat treatment at 80 degrees C for 30 minutes in order to remove the protein, mainly polylinase. These are enzymes which can convert polylen into another product in the fermentation broth. The supernatant was demelanized by with the hydrogen peroxidase and activated charcoal solvent blends are by solvent salt combination in which hydrogen peroxide treatment shows better result for the removal of melanin pigment. So this step we are using for the removal of the uh, melanin from broth. For the precipitation of the exopolysaccharide, the cold isopropanol was used, followed by its drying process at 60 to 40 degrees C. 60 degrees C for 40 minutes. This methodology produced high purity polyolane that was comparable in color and texture to the commercial sample, which was characterized by the HPLC and FTIR. So it was the example which we discussed that a bacterium which is producing some clouds and some proteinous material, what we did, which steps we involved, we studied, and these steps we in detail we discussed in our previous lectures and in chapter, and here we specified this with this example. So references, if you will see over here, these are our references from where this uh, course has been prepared. You also can find these references from any book. Principle of Fermentation Technology by Peter Stenberg, and this was the second edition and chapter 10, pages 277 to 308. You can read this techniques, these are techniques from this book. And second book which you can follow, Biochemical Engineering and Biotechnology by Castle Najib. This is the edition of 2007, chapter 7 and page number 170 to 189. You can read from it. This link also you can follow, and this is also another book, Research Journal of Recent Sciences. It have a good publication over here available online. This device, so these are references you can consider and you can go for this. Okay, this is end of the our downstream processing. and I will try to. I did my best to convey uh, available information into simplest form to you to understand it. Yes, maybe little bit you will understand from here. 10%, 20%, 25%, 30%, you will get some basic concept. For detail, you have to go through book. You will find in detail everything. And after going book, and you cannot find any answer and satisfaction, you have to come. You have to contact with me for details. We will debate it in our fresh classes, and I hope. For your better understanding about the downstream process. Thank you. Have a nice time. And you also have to read this thing in clear through books and through research articles and uh, through examples. And every student who is doing his MPhil study, any step is involved, when he is producing something from microorganism, so he or she is going to adopt some specific procedure for the isolation and purification of his desired product by various techniques. Some techniques you have already, you are in practice in. If any practice and any technique is new for you, just you have to go through book. You have to discuss with your colleagues, with your supervisor, with me, and from internet you can find. You have many sources to understand. Thank you and good luck. I wish you will understand it in a better way. Thank you.